Welcome at our core protocol sync. We'll share updates from the core protocol team from last week and plans for the immediate future. And the first one today will be Shamil.
Okay, let me share my screen. Last week, I finally made some final changes and merged PC certification PR, and it was tested by me directly and indirectly by Ivan. Also, I worked on this PR, which is modifying networking parameters. There were 2 iterations, and I think I'm close to finish it. Currently, treat we introduce some kind of connection threshold for networking peers, and if our connected peers this number of these peers are less than some predefined constant, we try to connect to additional batch of peers that are defined in a separate manager that uses those peers from local database and from the bootstrap nodes, some kind of additional connection manager. I think we're close to finish it. Also, I spent some time trying to just to debug this issue, which is we have on large plot size. A community member reported problems with 47 terabytes of plot, and he got some errors which look like connected to the P2P part, which is YAMLs of some kind of model of this stack. Initially, I wasn't able to reproduce it because I ran into yet another bug, which is connected to our JSON RPC crate. I managed to reproduce it and fix it, and currently I will be able to continue this issue. Also, I think I will work with some issues found by Ivan, which is additional issue with this YAMLs module from the P2P, and that with a problem that the relay node participating in the DSN, but doesn't actually answer to requests. That causes some additional problems on syncing. So there are several issues, and I will work with them this week. Also, last week, I had time and between tasks, and I spent time researching the Substrate sync protocol, because we will upgrade our current syncing solution in a more complex version. Currently, we use only first the closest peer from the DSN and try to request the data from it, but we will upgrade our protocol to some kind of more complicated version that we will get a collection of peers and try to make multiple connections to them and get all the data simultaneously. But there are multiple ways to do that, and we try to research what is the best and our optimal solution for that issue. I found out that Substrate has some similar ideas to ours, that they maintain additional protocol which called peer info, if I'm not mistaken, that peers maintain their state in multiple state that could be described and is max known block or current peer state, which could be idle or active or syncing. And when peers tries to sync with other peers, it gets this information first and makes the decision about syncing based on this information. So additional protocol on top of request response protocol that we have. This is one piece that I found out. It's very close that we were going to do, but it's not enough, and I will continue this research in my free time. So that's it.
Hey, Shamal, glad to hear you're doing that research. That's something we really need to do. Where are you documenting any of that, or are you right now?
I think I'm only since it's not some process, an active issue, I'm doing only several hours when I'm blocked. So I don't document it now. I'm just discussing with Nazar sometimes on our calls.
Okay. It would be really helpful if you could document that, or maybe if you could find documentation in Substrate about how that sync process works. But my assumption is it probably all just lives in the code.
Yep.
Because there are concerns about notions of finality and authority that are built into Substrate, which are more tightly coupled to like Babe or Grandpa, that we don't have, which impacts the security of our sync protocol. So it's kind of an open question. Like when we look at like the formal spec, like it just assumes there's a sync, but it doesn't say what that sync process is. But if that sync process is not secure for like non-proof of authority Nakamoto consensus, then it's not actually secure. So I guess what I'm trying to say is if you can document that, because that's an open question on the research side, is what is our sync process, or what's our current implementation, and what should the correct one be? So anything you can do to help document that and explain like how does it actually work right now in our implementation will be really, really helpful, because we're probably gonna have to change it.
Okay, sure, but I want you to clarify my priorities, because currently I'm doing that in kind of my free time. But if you want someone to find it out in some kind of very important matter, so please just let me know, and I'll dedicate a couple of days for that task.
Yeah, right now we are mostly concerned about sync on the farmer side, and we are just looking for inspiration in other places.
Yes, exactly.
Some of the sync process is actually documented in the history and sync in Notion. There are some links to the code, but it's not super comprehensive.
Yeah, I guess my point, Shamil, I'm not trying to reprioritize. I'm just saying, if as you do this, as you spend your free time researching this, let's just document it somewhere. Maybe at a later point, we will prioritize like systematizing that, but I just don't want this knowledge to get lost or just be in your head as we go forward.
Okay, that if I find something useful, I try to summarize it somehow.
Yeah.
I have another question to Shamil. The PR that you said about piece verification, could you summarize exactly what it does it do? Because I didn't see it, like in one sentence.
Okay, I definitely will send you a link after our call. But for now, when we get pieces through the thinking process, we need to verify that those pieces are valid, and we do that against the blockchain. We get this piece, and there is some function that verifies that this piece is valid. We are doing that using this notion of root block of the segment.
Okay, I see. Thank you. Does that like how fast is that? Just to understand.
We didn't benchmark it yet, but at least if I understood Ivan correctly, it's not the issue, it's a performance issue of that. We're doing that in batches. So this process in batches by the JSON RPC. So we make this call in batch. We didn't optimize it yet.
Basically, for any set of pieces, we just extract what the segments they belong to, and then extract roots for those segments.
Yeah, because I only know it from the like spec theoretical side, and it's a little bit hard for me to imagine how much time exactly various things do you actually take in code.
Oh, okay, if you need some timings for your work, we could do that probably.
I mean, not really need them, but I mean, if you had some, I was curious to hear them. But if you don't,
oh, I didn't benchmark it because currently we just created proof of concept for our algorithm, both on the verification side and on the thinking side. We will change it to optimize it drastically. So I think we just didn't spend time for that.
yeah, like no rush. Thank you.
Okay, let's transition to the other side of the sensing. Ivan.
Yeah, sure. Let me just share screen. So here it is. Last week, I opened several minor PRs, one of which was like very minor, related to moving the raising file descriptor limits from the inner functions into the main. So at the start of the executable, we just call the system call in order to raise the open file limit. Yeah. So this is pretty minor PR. And as I was testing the DSN sync last week, I discovered like several also minor issues. Yeah, one of which was that during handling new pieces, which we got from the DSN, we actually created some spans for the logs. So basically, by having that, we would have some more context. Yeah, but it actually turns out that this thing in a scene context is not correct. Yeah, it's a bit of tricky one, and basically using the prots macro from the tracing, it kind of handles that. Yeah, so it enters the span at the moment of calling in the future, so that we won't pollute other logs. So yeah, this was also a minor one. Yeah, and this PR, it will be merged soon. So basically, it does two things. First of all, yeah, just open the commits. Yeah. So yeah, the first one was that we basically discarded errors from the networking side. Yeah, and basically I discovered that I need those errors printed in logs so that I could determine what was the error. So I decided to just create a PR which would propagate the errors to the top, and they will be printed in the logs. Yeah, this was the first one. Yeah, and another commit was that actually in the same function which handled new pieces from the DSN, we actually ran the blocking function. Yeah, in the async context. Yeah. So basically, it's kind of incorrect, as it would exhaust the other asynchronous tasks. Yeah. And basically, apart from that, I was just testing the DSN sync, and I started it multiple times over, and basically this is the result which I got. Basically, at first I just tried to sync 3 plots at once, as I just synced from the node also 3 plots. Yeah, so I decided to go with the same amount of data and sync that also, and I just got several errors. So for example, this one, which is related also to the Yamx connection. So yeah, I actually discovered what's the issue with that. Actually, it is related to the running out of time for the request. Basically, we have a timeout of 15 seconds for the request, and we just basically hit the timeout, and after that we just close the connection as I suspect on the networking side, and that's why the Yamux module reporting that we have a broken pipe. Yeah, this was one thing. Basically, I discovered that and just increased the timeout, at least for me, for till the from 15 seconds to 1 minute or something like that. And error, at least for me, disappeared. Yeah, but it's a hacky fix. And another one issue which I discovered was that there was big probability of getting some plot hitting the relay node as the closest one for most of the ranges. So we basically won't skip. So basically we'll stop DSN syncing at the beginning because of that. Yeah, basically I created the issue for both of those. Yeah, and for this one, I already have the fix. Yeah, I just basically query in advance some peer. I try to create some mock request. So for example, request some pieces by range and just request empty range. Yeah, if the node just responds with none or okay result when it supports the request response protocol, and we're fine with just querying it. Yeah.
There's definitely a simpler, more appropriate way to verify that.
Yeah, true. Yeah, but at least I could test right now like everything. Yeah. Also, I didn't report that into that issue. I also discovered that actually sometimes nodes are basically disconnected, from each other, and they are reconnected like in 100 like milliseconds, and we might hit the error and stop syncing because of that. Yeah, so I basically also put some code which would like retry to query peers which are close to our requested key. Yeah, but with some sleep also there. Yeah, this is also a hacky one. Yeah, but at least it continues working for me right now. Yeah, so yeah, I guess that's kind of it for the last week. This week I work on the on fixing some of the issues, maybe investigating like new ones, tuning the performance, yeah, or things like that.
Did you find out causes for timeouts?
Yeah, I mean the timeout in this subspace networking actually. I
Okay,
mean,
but this is because of peer discovery or request response protocol timeout? Because those timeouts could be traced back to the answering peer, which could be a different farmer node.
Oh, let me just elaborate on that. I mean, it's related certainly to request response. I mean, we're requesting pieces, and I have suspicion that we're actually throttled by the semaphore for the disk. As I mean, at least I try. I mean, at least I use the like the old. I mean, the old farming structure. Yeah. So basically, it's basically it thinks that like all the plots are basically on the same disk, and we have the same semaphore. Yeah, maybe that's.
Semaphore has nothing to do with that because that's only for certain writes that are potentially random. And that's the only place where it actually blocks. When we are reading something, it doesn't actually use semaphore at all.
Okay,
so
okay.
it shouldn't be related there.
Okay, I guess I could. I should just look into the issue. Why it takes so long? I just request those things. Maybe it's related to the priority. Maybe
because you're testing on your local machine. You don't test it on some network.
Yeah, right.
Okay, so
I mean, it goes through the networking stack. It's just fast.
But it's not enough latency to cause such timeouts. Oh, it could be something with the usage of that request handlers.
Yeah. And though I understand correctly that we do not support any kind of resync on restart, right? That's just functional sync.
Yeah, but that's also a pain. Yeah.
That's a big ticket to handle.
Yeah, it's hard to, I guess, to implement it like nicely.
Hard or not, we need to handle that either way. There was also a pull request that you had for the graceful shutdown. We just had to close it, but there was some work there.
Yeah.
Okay. Any other comments on what Ivan has been working on? Okay. Ved, do you have anything to share this time?
Yeah. 1 second. Yeah, last week mostly focused on getting the proof of archival storage done. This essentially, basically what this does is when we finalize a block, when we finalize a header, we end up indexing those segments, as well as we use those indexed segments along with other segments that came out that are present in the non-finalized blocks to verify the proof of workable storage. This PR essentially handles that particular piece of it. And the next one was the verification of next digits. The current implementation, what we have is the runtime actually puts in the next digits such as randomness, salt, and the solution range before they were updating in the previous header itself. So we were just simply grabbing them up and then just using them when we were verifying. But when Nazar and I discussed, maybe it would be ideal to actually derive them independently on the light line to see if they actually match up and if they are expected at that particular header. This PR essentially handles that. Apart from deriving them on the fly, we also verify if they are expected to be present in that particular header. This was also done with the intention that Nazar could reuse it in its FastSync as well. So the API is abstracted mostly for that purpose as well. And the last one was when Nazar and I were discussing in this particular PR, we got to know that we also want to do some form of a storage bound for the light client. On some environments, could be a palette or could be something else where the storage itself is constrained. I started a little bit work on that where the light client also has some form of storage bound beyond the K depth to actually keep only those number of headers, but not all of them. Unfortunately, I didn't have a lot of time, and I'll most likely push that over in the next coming weeks, as I'm not going to be focusing on it this week. But that's been the progress so far.
Okay. Any concerns from anyone on the light client? Okay. Daria, do you have anything?
Well, I've been mostly trying to formalize the research documents to make them, well, developer friendly. So I was also looking at the libraries that we could use to implement certain things and try to write the specification more in terms of like APIs, those things. But again, when it's more or less done, and then the actual engineers will have to look at it, whether it makes sense.
Jerry, what was the initial reaction to looking at the Rust Filecoin proofs?
So they have this whole long replication process, and we would only need like some certain functions out of that. And so, for example, we might want to plug sloths in there, which they're not using, that we will be able to do. But in some things, it's still not clear for me whether we could, plug in or out the primitives that we already have from there, or whether we might have to re-implement those. So I'm still kind of trying to deworm those structures, so to say.
Okay, that makes sense. And if I remember from going back in time 2 or 3 years, they did have Sloth as part of their implementation at one point, but then once they transitioned to the stack DRG, it had so many levels that they didn't need Sloth anymore. And so they actually removed it from the implementation. It was just fast enough or slow enough, I guess, on its own. And I think they mentioned this in a few of the papers as well. So that it might not necessarily be a requirement, even though we put that in there just to think about it, like theoretically to time bound it. But from a practical point of view, the graph constructions are taking a long time anyways.
Because right now, for at the place where we are using sloths, they are using just XOR. So,
right.
Like just for comparison,
Yeah.
and that is a big difference if we want to go one way or the other.
Yeah. Well, we might even just, it might be useful if you could even just run like a simple test using their library with our input parameters, just generate like a 32 megabyte random file, put it in with the parameters, and just see how long it takes.
I mean, that would be interesting, but I'm not sure how I'm capable of doing that.
Okay,
Well,
I
you're all
didn't
from Rust,
realize.
so
No.
just go for it. It's a simple experiment.
Okay. Yeah. I mean, my one of the things that were slowing me down is that there are certain things between their spec, you know, and the way we name things that mean different stuff. So I'm trying to map between the concepts as well.
Yeah, we should use their spec or their naming convention, not ours. That was just my whatever I felt like at the time I was writing it convention. So don't look at that as canonical.
Okay.
Cool. All right. Looking forward to discuss that more on Thursday.
Okay, I think that's everything for today because I don't really have much to share from last week. So unless we have any other topics to discuss, we'll be closing the recording.
That's all I said.
Okay. Thanks everyone for watching on YouTube, and we'll see you next week.